Welcome. Please write down tonight's homework. Page 726 to 727, 5 through 17, and 19 through 28. Reminder that your quarter 4 review packet is due on Monday, and you will need to have that graded. I will have an answer key posted by Friday. And the state's project is due on Monday as well. Today, lesson 12.7 is on dilations. Our goal is to dilate figures in a coordinate plane. The vocabulary you need to know. A dilation is a transformation in which a figure stretches or shrinks with respect to a fixed point. The center of dilation is the fixed point of dilation. A scale factor of a dilation is the ratio of a side length of the image to the corresponding side length of the original figure. In a dilation, a figure and its image are similar, regardless of the value of k, where k is greater than 0. A point and its image after a dilation are in the same quadrants. In this lesson, the origin of the coordinate plane is the center of dilation. In the diagram, line A'B' is the image of line AB after a dilation, because A'B' over AB is equal to 2, the scale factor is 2. You can describe a dilation with respect to the origin using the notation xy will translate to kx, ky, where k is the scale factor. So example 1, draw quadrilateral ABCD and then find the coordinates of the vertices of the image after a dilation having a scale factor of 2 and draw the image. First, draw quadrilateral ABCD. A is at -4, 1. B is at 1, 3. C is at 1, -1. And D is at -3, -1. Connect our dots. This was A, B, C, and D. Then, to dilate ABCD, multiply the x and y coordinates of each vertex by the scale factor of 2. So our image will be 2x, 2y. So A prime will now be -8, 2. B prime will be at 2, 6. C prime will be at 2, -2. And D prime will be at -6, -2. Finally, draw quadrilateral ABCD prime. So -8, 2, that's A prime. 2, 6 is B prime. 2, -2 is C prime. And -6, -2 is D prime. Connect our dots. Notice in example 1 that the k is greater than 1. The new figure is an enlargement of the original figure. Draw triangle DEF. Then find the coordinates of the vertices of the image after a dilation having a scale factor of 3 and draw the image. DEF is at -3, 2, 1, 2, and 1, -1. Connect our dots. So D, E, and F. Find our scale factor of 3. So D prime will now be at -9, 6, multiplying everything by 3. E prime will be at 3, 6, and F prime will be at 3, -3. Graph those points. So -9, 6 will be D prime. 3, 6 will be E prime. And 3, -3 will be F prime. Connect our dots. And we have our enlarged figure. Example number 2, using a scale factor less than 1. So we will graph the points for PQR at -8, 4, -6, 6, and -4, -2. Connect our dots. That was P, Q, R. And then they want us to use a scale factor of 0.5. So we will multiply each x and y coordinate by 0.5. So our image will be 0.5x, 0.5y. So P prime is now at -4, 2. Q prime is at -3, 3. And R prime is at -2, -1. Graph those at -4, 2. That is P prime. -3, 3 is Q prime. And -2, -1 is R prime. Connect our dots. And we have a shrunken image because K is less than 1. Computer graphics. An artist uses a computer program to enlarge a design as shown. What is the scale factor of the dilation? The width of the original design is 3 minus 1, which is equal to 2 units. And the width of the image is 9 minus 3, which is 6. So the scale factor is 6 units over 2 units, or 3. Given that line CD with endpoints 6, -9, and -3, 1, with C prime D prime with endpoints 2, -3, and -1, 1/3, be the image of line CD after a dilation. Find the scale factor. So really, just find the difference in the points. What am I doing to 6 to get 2? What do I do to -9 to get -3? What do I do to -3 to get -1? And what do I do to 1 to get 3? All of them I am dividing by 3 or multiplying by 1/3. So it has a scale factor of 1/3. A summary, transformations in a coordinate plane. In a translation, each point of a figure is moved the same distance in the same direction. So we end up with x plus a and y plus b. Reflections. In a reflection, a figure is flipped over a line. The reflection over the x-axis will be x negative y, and the reflection over the y-axis will be negative x, y. Rotations. In a rotation, a figure is turned about the origin through a given angle and direction. A 90 degrees clockwise rotation, xy becomes y negative x. And in a 90-degree counterclockwise rotation, we end up with negative y x. A 180-degree rotation, we end up with negative x, negative y. Dilations. In a dilation, a figure stretches or shrinks. So xy would become kx and ky, where k is the scale factor. Reminder, tonight's homework is page 726 to 727, 5 through 17, and 19 through 28.